What is SPIDAR series, short for Space Interface Device for Artificial Reality? It is a series of devices that use wires and motors to realize one or multiple dimensional force feedback. The series include many types, such as multi-finger type, grip type, mouse type, and new types ongoing. SPIDAR-I is one of the newest haptic device in SPIDAR series. It is a grip-type interface which use 8 pairs of wires and motors to realize 6 degrees of freedom force feedback. The 6 DoF realized by SPIDAR-I contain 3 DoF of translation and 3 DoF of rotation. Furthermore, SPIDAR-I is also a desktop-sized device. This device is designed to be used like a 3D mouse, which needs only to move our wrist to do the operation. Another merit of SPIDAR-I is that wires are placed in the inner side of the grip, so users don't need to worry about touching wires by accident. The main purpose to develop SPIDAR-I is to optimize the structure of grip-type haptic device. The first version of SPIDAR-I Igarashi type is designed analytically to improve performance of calculation. The second version Koyama type is designed for isotropic force feedback with respect to directions of x, y, z axis. The standard of optimization used by the proposal version is isotropic peak force feedback, which means to minimize the margin of peak force of all directions. The parameters used to optimize the structure of SPIDAR-I are 3 angles phi, theta, xi shown in the following picture, which define the direction of each wire, where d is a tangent plane of the sphere, phi 1 and phi 2 are symmetrical about y, z plane, phi 1, phi 2 and phi 3, phi 4 are symmetrical about x, y plane. Phi 1 to phi 4 and phi 5 to phi 8 are symmetrical about x, z plane after rotate 90 degrees around y-axis. The results of optimization are shown in the table below compared with prior types of SPIDAR-I. It is obvious that values of parameter phi and xi are same to all 3 types of SPIDAR-I, but the value of parameter theta are different. The theoretical values of minimum peak force of all 3 types of SPIDAR-I are shown in the following table. Obviously, the proposal structure has the largest theoretical value compared to prior structures. The following table shows measured values and theoretical values of peak force in x, y, z directions and moment over r around x, y, z axis, where r is the radius of grip. The maximum error is about 0.3 Newton. The possible factors of the errors is the friction of guide rollers and wires. Generally, we are able to conclude that the results agree with the theoretical values. What can you do with SPIDAR-I? SPIDAR-I can be connected to VR worlds such as game engine Unity 3D. What needs to do is simply installing the driver and loading setting files to a project of Unity 3D. One of the demonstrations is a puzzle game. And billiard. And Sokoban. What about more cases? The more cases you push, the heavier you feel. This can only be realized by haptic interface.